Today we'll be talking about how to build award-winning websites with React and GSAP. So if you are working with React, I hope basically you have gone to the website called Awards and seen those crazy websites with animations and all those interactions and thought of like how do these guys build these things and pretty much that we'll be talking about how to go about and build those things. Uh, so a little bit about myself. Who am I? I am a software engineer basically. I work with Android and big data, and I'm currently working with different trend systems. And in my day-to-day job, I'm working with web animations and interactions. And so let's start with the animations 101, like how they work. This is the very simplified overview of how animation works. So basically, there is an initial state of anything on a screen. Like this is a screen, and the red gradient rectangle you are seeing on the left. This is the initial position of that rectangle, and while animating it will be in the animation state and on the scene, and after it exits the screen, that will be the exit state for that particular object. So you have to keep in mind all these three states, and basically these will be the starting point for our animations. And like I said, the initial and the animating and the exit states. This is how this works. And so we will be using the GSAP. So what is GSAP? So GSAP is a GreenSock animation platform built by the GreenSock company. It's a industry standard for building JavaScript animations and all those UI related things you see. So let's see, we can see the showcase many of the things that are built with the GSAP animations, all those award website that you see by the creative developers. Like let's look an example over there. Like, these are built with GSAP, all these animations and interactions, uh, right? Like these, all these are built with GSAP and JavaScript animations, and we'll be looking on the how to implement this slider as well. And this is some higher order stuff that is built with React and 3GS as well. This uses WebGL. We'll talk about that later in the slides. So you can see like this thing is most common nowadays, like this and this type of animations of interactions. Like so, we'll talk about how these are made as well. And let's start with the yeah. So with GSAP, we basically have two things that we have to keep in mind while starting. There's a GSAP timeline, like from how much duration the animation has to run, and the from state and the to state. From is basically when the object is loaded onto the screen, rendered onto the screen. That's the from state, and from where we want that animation, that object to end with. That's the to state. I hope I'm making some sense over here. Like it's basically as simple as that. From where we want to move the object and to where we want to move the object. Yeah. So as I said, we will look how to implement that slider, like slider we saw it just now. So it's just like two lines of code with GSAP that we can implement this thing. Like this is the only thing with GSAP we need to implement with this use effect. Like first, we need to pass a ref on the component that we are trying to animate, and then we need to create a timeline for the GSAP. This repeat here means that we want to continuously repeat, infinitely repeat the animation loop, and then we just set the current position of the x-axis to 0, like this position, like we want the when the website first load to be on this x0 position, and then after that I want the object to move the negative 250 pixels in 6 seconds. And so this object which I have made is 250 pixels, so I want this to move to the left of the screen so that it goes out of the screen. And I'm just repeating that for 6 seconds, and the easing is linear. You can change anything you with the easing, like there's many eases for that. And duration you can change as well, like you want it slow, you want it faster, and that's how that simple animation is done. Like you can just replace it with the svgs component, and then we can have that slider as well. And one of the implementation for GSAP is like the photo reveal. We see like many on the many websites we see, like while we scroll through the website, there's an animation of the image reveals. And so this is also done with GSAP, and it's pretty easy as well. Like I said, we need first to define like where the image will be visible when the page load. So we are setting the visibility to visible for that container of the image, and after that we are telling GSAP that to decrease the width of the container in 1.4 second. Like how this works is like this is an image, and over that I have a container with the white color as well. So what I'm telling GSAP is like to decrease the width of the container that is on the top of the image to 0% in 1.4 seconds. And as I said, that you can just use the easings with the GSAP, like easy in the out and linear and bounce and spring, all those animations. And this is basically how it works. This is a one liner, and like this looks so cool, right? And as well as I'm saying that for the image, like I want the image to move from what this from means, I want the image from when it load to be a scale of 1.6 and move down to the scale of 1. And when it's low and it completely loads, it's a 100% scale, one scale. Like this is how it's simple with GSAP. And we have pretty much basically pretty much the GSAP docs are very you can elaborate. Like we have much functionality written over that. The tween is basically used to get the animations from, and we have pretty much good examples like how to animate all these multiple objects like this. And one of the major use case for the like the stagger animation, like if I run this when you're a content library and you want to animate that, like this will animate like this. So this is very bland, as you can see. Like this is very linear. And if I just comment this one out and I just add a this functionality, this tagger, what will it do is like it will just delay the animation on the uh, next object by zero point 0.2 seconds. Like we can see how this simple stagger um, will affect the animations. Like you can see, like after this is loaded, it is the next element is loaded after zero point 0.2 second. Like yeah. So GSAP makes it more simpler and easier to write all these animations for us. Yeah. So to understand that, GSAP offers multiple plugins. Like there are currently 19 plugins as of now. Uh, the main plugin that is used with GSAPs are the scroll trigger and CSS rule plugin. Scroll trigger is basically used, as I showed you earlier. This functionality, uh, this scrolling and animating objects while scroll is done by scroll trigger uh, on the basis of the position of the current scroll that we are getting. Like Bhargav recently showed that the use mouse basically that is the functionality that scroll trigger provides, the mouse position and the scroll position of your current position on the screen. So this is done with that. And so you can ask a question like, I don't want to use a GSAP because there can be many reasons. Now what? So there's another library called Framer Motion that is quite popular with React, because we have quite a few components as well written with the Framer Motion. And you can go about use the Framer Motion, but it's in the very early stage, and much of the functionality, I would say the, how can I explain? Uh, GSAP provides you much more flexibility to animate the objects like the way you want. And if you only want the scroll animations and all these scroll things, then you can check out the locomotive scroll. Like these have all the scroll positions and the parallax effects written in hooks and easy to implement. Uh, you can check out this library. It is open source as well and quite a good maintained library as well. And after that, there is the 3GS and the React 3 Fiber and the WebGL part of the animating with the web. So up until now, we saw like how to animate in the 2D space and just move the position, rotation, and all those things. But on the some sites, like on the earlier website I'm showing you, there was the image that was waving. So these cannot be done with GSAP or either with frame of motions. So these are done with 3GS and WebGL, typically written with these things. These type of things are done with WebGL, GPU acceleration for the web. So like you can see the blobs are entering and animating and the mouse interactivity. All those things are done with WebGL, and this uses the your GPU as well while rendering. So these are written with the 3JS and React 3 Fiber. For the React 3 Fiber provides the overlay over the 3JS library, and this is the example that I was showing you. Like this is what we saw earlier in the website over here. Like this is how they are doing it. So let's see. So this is how it's done with web GL and 3JS. So basically, if you don't let me just show you this thing. So basically, 3JS wraps around all the abstract, all the code that you need to write, and it's just this simple. Like you need to render a canvas, and under that you need to provide your wave component. Like this is as simple as that with React.js. And here you as we in the GSAP, we were defining the refs for the current div. So that's how it is done. But it's not that easy, because for these type of things we are using all these web acceleration, shader calculations, and much more. So these things get pretty math heavy, and the more complex architecture you are animating and more 3D things you are getting into, these can get performance heavy as well. Like this is all the code for this shader materials that we are writing for the GLXL library that we are importing from the 3GS. Like we have to check with the GPU as well. Like this single line is checking with the how much GPU you want to use for the rendering of uh, this particular div element for the image. And after that, we are using all these noise components, sine waves, and this can get pretty much as math heavy as you can get. And if you are pretty good at math, you can create anything you want in the WebGL side of things. Yeah, so pretty much how these things are done with the WebGL type of things. So from here, where you want to go. So you can check out the Godly website that we these are the pretty much uh, a collection of all these creative website and developers that are doing awesome stuff in the web animation and interaction spaces, and you can learn from that. Sometimes they share their components and how they are building these things as well. And people to follow in the creative dev spaces are Ron Akram. Basically, he's the one that developed the um, wavy image that you saw. And Daniel is also one of the creative dev that deals with the 3D web designs and all those things, like 3D animations you see. And Benoist is one of the great creative developer. You can follow him on Twitter, and you will see that many of the sites that you have visited is creatively developed by him as well. And OK Devs is a community of all the creative devs that you can be part of. And I think as a front-end developer, you should be part of some of these communities, and they help you think more about how to implement these UIs, and help you learn more about how things are rendered on the DOM, and how to make them performant and as well as good looking. So thank you. That's from my side.